And then we queried it through our file system. Yeah. So there is no anything like default, but the table name and the file structure matches the same. Yeah. So because that also the default database and the file structure. Yeah, that's how it happens in the Hive. So like okay, so just like 2 minutes overview of Hive. So Hive is again a data warehouse, a Hadoop based data warehouse. So the way it is correct, so you have this mapping of this directory, this file, and when you create table, correct? So when you install Hive, correct? So you install Hive, and Hive has got a metadata. So when you install Hive, you need to install another NoSQL, another RDBMS system. So either SQLite or like Oracle or like where it stores your metadata information about how you are mapping it to your tables, to your directories here. So there is a concept of managed and unmanaged tables and like all those things. So in a nutshell, so so the way this all this works, Hive has got these metadata tables stored in RDBMS, either MySQL or like SQLite. When you install Hive, it will have that configuration for you. The metadata has certain information which maps table over the file. Yes, yeah, table, and when you write your Hive queries, correct, create table, it will take care of all. I will show you right now. All right, so all right, so here I am doing if everybody is like logged into it, so just follow those steps. I think you already shared the yeah, so instructions here. So if you follow even at home, correct, all these instructions, you'll be able to create tables and like play around with this. So let me do that. So the first thing here, we will type in Hive. So I have logged in to 02 cluster. Let me show you here Hive. So basically, this is your Hive shell here. Like how any database shell you have, you have your Hive shell here. So what is that URL directly going to the browser? And this are both the same, or no? This is your shell here. So shell, but like whatever we type, like select start from sample. Yeah. That also like similar. Yeah. It will come, but I will show you of actually how to create a database, create a table, and how to query it. So the fundamental concepts will be there, and then you can work on this data sets, upload it, and then you can see that. So once you have this correct, so always use this set hive.cli.print header equals true. The reason is that when you set this up correct, set hive CLI print dot header equals true. When you write select star from, so it would display your column names as well. If you set this up, yeah, here this one. Yeah, I will put it. Yeah. So when so if you do select star, it will properly display for ready printing. It will give you column names and everything. So now we will step one. We will create database. I'm doing. You can try here, but please use different database name here. Otherwise, it will clash with. So create database. Yeah, something whatever you want to do in that way. So I'm doing here create database DM. DM is for data mining. So create database DM. I will put it in. So this has created table here. I'm going to. These are all Hive commands. Show databases. So currently it will show. Okay, I think Amit has created database. Amit underscore DM. DM is there. That's what I created. And then we have databases here.
So I will be using use DM. So I have changed to this. These are the standard.
So which server are you using? I think I don't see that table.
Yeah, I am in 2.
Okay.
You log into 1.
I think we logged into I think section. I think we are logging in. So that's okay. Right? Your Java itself.
Yeah. Yeah. So just like as you mentioned, do that your name there. Let me know if you have any challenges here.
Keep opening that from browser as well. Even from there also it will be the same thing. So the moment you create here
Yeah.
or you create there, it reflects in both the places. Okay.
So now I'm creating table here. So if you look at this command, correct? I'm doing create table dm.customer. This is a sample table. Customer ID, some household ID, so that I can query on that. Gender, first name. So the important fields here to understand is like row format. So basically, when you create a table, at the end of the day, you want to populate that table, correct? So the way you populate this table, you have to give row format delimited. So whether it's a and like fields terminated by. So here I am giving a CSV file here, comma separated. You can have your pipe or like any kind of field separated. Should be fine. Then lines terminated by carriage return and stored as this is simple text file, but you will be having ORC or Avro format based on your format what you need. Yeah, these are the yeah. This will create a table.
But we can alter later also.
Yeah, you can do that.
Unless that is
Yeah.
it's always created that as our format, but it's not going to get
Yeah. So I'm doing copy paste here. Create table, dm.customer, customer ID, household ID, gender, first name, then this comments row format delimited fields terminated by comma, lines terminated by category return and stored as format, and I hit enter. So it has said table has created. Then this is also an important command describe extended dm.customer, correct? So if you want to know what is your table structure, so like you are working on a project where you want to understand your table schema, what is the path, everything you can get it using describe extended.dm table name. If I do this, you get all the information for your table here. So one of the important field which I want to highlight with this, correct? So this is your storage here, location. Look at this location where this table is. This is where the table is created. Hive warehouse dm.db customer. Now let me have another terminal here. Usually what I do here, I will go to new. I will create another terminal and I will do a SSH to that again. Yeah, 1 minute. Yeah, here. You want no. Yeah. You had any question? Okay. Okay. Yeah. So here if you see, correct, in this terminal. So the point I want to make here is that this is your storage block. This is where the location is. This is kind of fundamental concept here in Hive. I think if you, that's where the people like who are new to Hive, they try to get it done. WASB, this is your file path to it. Now, earlier I showed you Hadoop commands, correct? This is for Azure storage. So yeah, blob. Yeah, this is where you give the file path if you want to access that. So now, if I want to get the contents of this, correct? So what I'm trying to go here is that I am going to Hive warehouse and then show you the actual directory it has created for that table with customer. That is where the main thing lies there. Huh? Yeah. So what you can do, don't come out of the Hive, create another shell, another terminal, and then you SSH to that, so you can play around with that. Like say for example, what he's asking is that we have Hive terminal, correct? Do I have to come out of that terminal to do this to run Hadoop command? So you can open multiple terminals. Yeah, that will be there. That will also be there. Yeah. So now if you look at this, correct? So this is the directory it has created. Amit underscore dm.db. If I go inside this, currently it will be empty. So this is what the directory is, but there won't be anything here. So nothing is here so far. So it's like empty. So our next step is to populate this table here. So, and what Venki was saying, correct? So if you want to go with this, so there is one more command where without going here, if you do here with hive -e, and then you can execute your commands. Yeah, outside you do not have to log into hive and then do it. You can do it like this: describe extended and any command here. So it will launch that. So it will give the output for those. Using that. Alright. So now let's populate this table, and then I will execute. So currently, if I do this, correct? Select star from customer. I won't get anything here. Huh? This one? Here it will be. You want the path? Here it will be one. One. Yeah. Here. Yeah. Okay, Anna. Huh? Here. Here it will be. So currently this is empty. So now if I do this, select star from customer, correct? Let me go to Hive. So since we have used that command, correct, for the printing of columns. That's why you see here column names. This one. Which one? Mine is 02. You can log into 02 as well. Username, password is. Okay. Yeah. So now let's populate this customer table. So let's see here. Here in this, I have already populated this. So if you are going through the schema, correct, in this training under Hive, this is what our data sets is. Here, the data set. Customer, click on view raw. This is like 9 MB of data. So this is just a sample data here with the customer ID, which maps to. So let's populate this. You can click on this and let's see the data here. So usually, FileZilla is also a good tool. We will now connect to FileZilla. It's FTP tool if you are not aware of that. So FileZilla is a tool where you can import expression. You can use Skippy also, SCP command to upload and download files. Yeah. So let's connect to this cluster. So in case like people who are new to FileZilla, correct? Once you download it, click on this and like click on your cluster here. So I will be using 2. So we can wait if you want to download your file. FileZilla, I think you can just download it. Let's search for FileZilla and then you can download it. SSH user, and our password will be no, from a local machine. So like we have this data set. Yeah, yeah, small one. Yeah, small one you can create. Yeah, yeah, yeah. I'm just showing how to do it from local to Hadoop cluster. So yeah, so basically this is the
No, 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 no. What is doing is what is the file to local. Once it brings that file, then it file into some.
yeah.
Copy to local, copy from local. What I'm saying is, first is getting those files to local system.
Yeah, yeah. So here, yeah, in this local folder, I have this data here. So like in the basically in the real world also you will be doing the same thing, right? So like you have this file, this is on your local laptop. You want to upload it to your cluster. This is what the project you will be doing, correct? And then somewhere you have this. That's why I'm just putting it here.
So on top of that,
Yeah, so you have this.
we have the ETL tools as well. Okay. This is a command line interface. What this is a command line. Then immediately I want to copy the
So
file.
you have this data sets, correct, for internal and external. So now that file you will be uploading to your cluster. Because everything is in cloud, so you have to upload your files here. This is one of the way you do it. Even for like any web server, correct? Like you want to upload any files, so you upload like any jar or something to that. Hmm? Yeah, yeah. SCP is like similarly you do it that way. Because this is Now what I will be doing here, correct? So like usually now we have this our home directory, home SSH user. I will create a directory on cluster data and then I will upload dm underscore customer dot txt. In the real world also you will be doing the same thing.
If I have to load the data externally, like how are you going to load the data?
Externally?
Externally, because like here we created the table, and then we are copying the data there. Now, like how are we?
So you can map it that way also. Yeah, external table.
Even internal table only. Like suppose I am copying my data on the CSS. Like how this table and that data is given. Okay.
Yeah, you can map it.
You can do the file name. No, while creating the table, you can map the file to the table directly. That will take care. So that is optional. Like if you are not using any file name to that, then just use the table with column structure. It will not contain any data. Then either you can use insert into this or copy from this table to this table. Like the normal how it happens here. Just you have the staging table. So you copy the data from the file to the staging table. Or you just drop and read the table, map into the staging file. And then the moment you insert copy the data from that table to this table, you just go back, you create a file. Forget about all this thing, just create one blank table and write insert. Before that, you go to the structure and see how many files got created. It will be 0 files. You just fire one command, insert into the table, just give some value, one data. What it does is, it will create one more file. Then you see the file over there. And once again, fire the same command. It will not append to that file. It will create one more file, which is that folder. So that means the more and more you keep copying, somebody keeps creating the files. So those files will be mapped to that table.
Yes. That's how the Hive metadata.
Hive metadata will come from this is the table. And this is the DB. Under this DB, this is the table I have created. For this table, these are the list of files now. Could be any number of. That is what I'm saying. Fire the insert, you do not, it shows as if the report was inserted to the table. But internally it created file. So if you create, if you fire once again the same command again, you create one more file. If you know what every insert will create file. Yeah. Eventually it will be overhead, right? Because here everything is file system. The only thing is, earlier what was happening is, if you go for map tables and all, you can use the file name for the processing and all. So the users are finding it very difficult. They don't know how to map and all. They just know the SQL, select start from table. So to make it easier, they created one more wrapper on top of this. Hive is just a Hive is nothing but the people who are familiar with SQL. Select start from new. For us, it's just like select start from new, but internally it goes to the file and gets the data. So one select might be this will internally execute a lot of images. So one question, you cannot use this file upload. You cannot do to NTF system. You just go to a user only. No. For Hive is doing it for local file system. And from there, it does it to SPF. No, but can we do using this file Jira to
Yeah.
Directly without giving copy to local command. Yeah. From here, from local folder, you directly go to HDFS. Directly copy.
Yeah, say, okay, if you want to do it that way, correct? Usually the way I'm showing it, you are doing like FTP and all this. Second way is that usually if you want to do it, second way you upload your data to blob.
Okay.
From blob, you can, because blob is your central thing. From blob, you can access it again.
No, I can't. The moment you copy to the blob, internally it is already mapped to the SPF. Okay, that takes care of for distributing the data. Here we are not, there is an option where you can upload the file from that blob. Go to that page and from there you select the file. The moment you copy the file to that blob, it is copying to the SPF. It is not copying to the local, it is copying to the SPF. But here, if you do global and then you copy into our SPF copy command, right?
Yeah. I will show you using Hive command how you do it in the real world. I believe in the real world also something like that you will be doing it.
What is the list of file commands? List of files?
Yeah.
No,
So here, so now I am creating.
You just have to select the folder. You first select the root.
is not a way actually. How you try to understand. Right now there are no files. You don't think the high. You just dump the file. And then when you do the representation, you create the alternative. On the fly, it will right now there is no data in the customer.
But you want to upload it now?
No, it's not upload.
Oh.
Then you drop the table. Right? So if you
Yeah,
want
go
to
ahead.
database and the file, you drop the table.
Yeah. So like currently, like
I have one file.
yes.
Suppose when creating the table you have given 3 or 4 attributes. Now, suppose my input file is not matched with that comma delimiter. Like my input file has just like 1 or 2 delimiter, only 1 or 2 attributes with comma. Now, because my table structure in my input file is like both kind of mismatch. Now, in that case, like how is it going to input the data?
I believe no. His question is what he's asking is that we have created a structure here, correct? Like create table and then we give customer ID, gender, male with varchar and everything. So now, yeah, one more. So now, if the file is not clean properly, and if there is some issues with the file itself, is there?
One more column I will.
No, like kind of like that. My input file is like an unstructured. It's not in that.
No. Okay, what is the unstructured and structured?
No, when I say structured, just like it's with comma, like it is exactly
No,
matching
it
the
is not
code
structured with that sense. In the moment when you say unstructured, whatever the file that I'm sending, right now I'm not defining any column. Just dumping the file, whatever it might be. When you want to analyze the data, you should be knowing. You should know, like, okay, this is the file I have. This row contains 100 characters. And I have not defined any structure to it. I'm just saying, okay, this file contains 100 characters. Now you define out of these 100 characters, what you want. You want to say like first 5 characters belong to something. Next 20 characters belong to something. For you. For me, first 20 characters might belong to something. As per my analysis. So that is what we say, like we are not defining any structure to that. We are just uploading the data as it is. Let us retake like how we want to define the structure.
Okay,
So,
according to that,
according to that. So next comes okay. By creating a table, we can say like, okay, this is a table, these are the columns I'm defining, and this is delimited at 7 columns. So that means we know already. This file contains, the moment if it doesn't fit that thing, then there are some. So
okay,
not
that's
even
what like my question is, there is a mismatch, then how is
then go for error handling. So, but by loading the file to the SPSS, then it doesn't take all the code. It just loads the file to the SPSS. From the SPSS, then bringing it to live now. So analysis
So
purpose.
when we define the table, we should be aware what the
Yes.
file structure is.
Yes.
It's not the other way.
Another way. So
I am not injecting the file based on table. I am defining the table based on
Yeah.
Location.
That is when you point the unstructured. When I go for Oracle, I already defined
define the structure, right?
So that is why you point the structured and unstructured.
So basically it is the read definition what we are defining here.
So my question is that see, what location that you provided that okay. If suppose instead of inserting, we upload some file, and if you run a high command will automatically take it.
What I could not get it.
So
Yeah, I will show you that currently.
Define external table.
Yeah. Yeah.
You have to define external table.
Yeah.
Still, I think you want to complete
yeah,
whatever
even if you
it
pass
is. Because if you keep asking the same thing again and again, then you might run out of the time. But I can complete.
Yeah.
If you're
So,
complete,
yeah.
we can range it.
Yeah. So now I have created a directory here. So like, so this is what you will be doing in the real world. So I am uploading one text file here. So this one. So now this is uploaded, correct? So now we want to populate our table. Currently the table is empty. So like if you look at this, currently table is empty here. Nothing is there. So the command to populate, correct? This is where we do it here. Load data local in path. So this is what the magic works here. So what we are telling here, load data is a Hive command. Local in path, this is where I have here this text file. I want to overwrite into this table which I created. So this will populate our table.
So
In the real world also, yeah, you
local
will be doing.
actual local user.
Yeah, local. So like if you like, currently I have uploaded this file, correct? Let me go to another directory here, another terminal. If I do ls, we have data I have created. cd data ls. This is where our file is. If I do cat, this is what our file is. But in the table is not there. We have to populate our table using this one. To look at this home SSH user data is there. This is what I am giving path here. home SSH data, the file name, overwrite, because I want to overwrite the table into the table which we created earlier.
So same thing, if it is terminated by comma, the file is coming semicolon or something different.
Yeah,
It
will not go the direct to this table. It will
Hmm.
stay. But that file will be there in this table.
Basically, we are creating the file. That's it now.
Hmm?
Then we execute this.
Yeah, so now we are populating the table. So let me execute this. So now it says loading data to
And
table.
will this file will still be there, or it will just move from there?
No, file will be there.
No, because the command is only from here. It is not saying delete. You can delete it.
Yeah. So now,
Now my next question.
Yes.
Suppose instead of this, I just simply use this command
Hmm.
and just copy from that path to my this path where my table location is. How you look at it?
yeah, that should also work.
It should automatically
Yeah.
take the data.
Yeah, it will work. I'll show you where you mean higher warehouse there,
So
correct?
whatever path here.
Yeah. Yes. Okay. So now let's run this query. Select star from customer where customer dot first name equals Daniel. So so it returns all the
So this
first.
is our location, different location.
Yeah. So now this file is created, correct? So now let's go back again to this where we earlier had this.
Now it is doing that.
Hmm?
Now I can see.
Yeah. So now that file is there in this location. This is what I did that here. So now if you put anything here, it will be mapped to that. So you fill that data. This is very fundamental
So
concept.
now, let's say in the customer.test, one two column added,
Hmm.
right?
Hmm.
And if you do select star from
It will take that. Huh?
select star from customer,
Hmm.
so this table
That time it will give error.
So that will be
error or it will only show the 4 column.
That I have to see. I'm not sure of that. But what I understand from the week you can do it. But what I understand, Hive is always a read only. So there is no schema as such. So you just dump in, and when you read, that time you will get an error.
Now, can you do one more thing?
Yes.
Can you just copy that same file with a different name? The local edge system.
Yeah. That also we can do it.
Can you just select count and then you can do that?
Hmm. You are logged in, correct, Anand? To that. So yeah. So this is the one thing. Let me move on to some of the things here. Because you want me to take partition, bucketing, and all those things?
No, I think that you can take
I think we'll focus on the
Use case. So use case, you know how to upload data set and everything, correct? Yeah. But before that, like some of the basic things about how I want to just show you quickly. So that you will be using when you have JSON. How you store JSON data in your table. What is lateral view? That I want to just quickly do it, array, map, and everything.
Can you go a little bit over your bucketing and partition structure and
Yeah, I will just take 2 minutes. You want to take this? Whoever, yeah, go ahead. Yeah. Not more than 5 minutes.
Sure.
It's the same concept like database. The partition is more the same concept like database.
Performance tuning.
Performance tuning.
You can optimize your querying pattern. So normally when you have these tables, right? Let's say this is a table, or let's say the DB, and under that you have multiple tables. You consider your major table, and you are trying to query the table, and you see some drastic performance degrade in your query as the data grows, right? So what you can do is probably the first technique, the basic technique what we use is partitioning. So we create partitions. So when you create partitions, you look at your query patterns. I mean, on what pattern you're querying that particular table. Based on that, you try to partition your data. So what if you do is, let's say you have a location-wise or any timestamp specific pattern of querying the data. So you create that partition. And what you do is, it will try to place the data into multiple partitions in a way that whenever you load the data, in these partitions, again it has the static as well as dynamic. Static is something you say that load the data into this particular partition. You say where this partition is this particular location or this particular partition. And it will keep loading. Means partition is nothing but it is going to create subfolders for each of the partition. For that particular, you're saying that warehouse dm.db/customer, right? So within customer, you will see multiple partitions. Then it is physically stored. So when you are querying it, you will mention in the where condition for that particular partition, right? It is going to pick only the particular folder data, not every other folder. But when you normally don't have partitions, you will try to pick all that data, then filter that required thing from your where condition and show you. In case of partitions, it will pick only that particular part data. So that is about partition. And dynamic partitions is you should have a staging table. You have to say, I'm going to partition this particular data on this. You query on that staging table, and then it is going to dynamically load. You don't have to specifically say into this partition. You have this load, right? Load data, local import of load data into from directly from the storage. So in dynamic partitions, you will have a table completely loaded data in this. And from this you query and you put that partition in the column. So accordingly, it will map the data when it is loaded. That is the dynamic. So you can just have a look at it. Okay. So that will be there in the Hive wiki. So the Apache wiki, and there you can easily do it. Coming back to the bucketing, it's even further granular way of looking at the data. Here you will use your reducers. Please correct me if I'm missing something.
Yeah.
So here the bucketing concept is nothing but when you are processing your data, right? So in map reduce, you have this map and reduce, right? Mapping is gathering, reduce is nothing but aggregating your data. So while aggregating your data, you can partition your data, right? So how many number of reducers you give, in that way it is going to partition your data. Similarly, you can create buckets for your Hive table. And what the buckets is going to do is, the whole data that is there in the table, let's say if you said that include these many buckets, let's say 3 buckets, that will give modulo of 3 on the, let's say, the key.
He doesn't know which column to put. I have set up that. But he doesn't know like what partition to run. And it's just like, okay, divide this into 3 sets. That is when this bucket like that. If you want to 3 sets, then modular of 2. 5 sets, modular of 2. So that is the this bucket.
And any given time, either you use partitioning or bucketing.
No, it depends on how the data is. Let's say your data is classified by year or month. You know the rule, right? And you do the partition by year or month. Other case you don't know. Data might come any year, month, right? So you just divide the table based on the bucket.
Okay.
1/5 of the table. So you divide 5th, your record might come to the 5th, right? You give the bucket 5. Won't search your whole table.
If you go to the bucket file, we have a surrogate key column. The surrogate key. You just implement that. And we know very well that surrogate key is unique. So now I got 100 records. So unique construct is surrogate key. You just like your sequence generator. So what I'm saying is, just distribute this data into 3 buckets. Record 1 to this, record 2 to this, record 3 to this. Again, record 4 to first bucket. Record 5 to this. So here, we are not duplicating the data. We are ensuring at any given point of time, the record exists in only one bucket. Because the primary key itself is surrogate. So that is where this bucket is.
At any given time, I can apply you within the partition. I can apply this bucket.
Exactly.
I don't know. I never use both. You can use it.
Let's say in this particular bucket itself, partition itself, the data is heavy. So you can use a combination of buckets as well, so that you get better performance.
So how that, so you have 3 partitions. Let's say you created the yearly partition, and 100 record each, and you created 3 buckets. So bucketing will apply all complete table like all 100, or it will 30 record.
It will be directories. Yeah, it will be directory, subdirectory, that way.
So 100 divided by 3, 33, and then you have 3 modules, or 3 buckets. So the 10 record will come there.
bucketing, right, there is no guarantee that how many will come. It purely depends on the hash code of that particular column on where you are bucketing. And applied by that module of number of buckets is specific.
But typically we use what? Normally partition.
Basic thing is applying partitions. If you want to tune it further, apply buckets.
Let's say, I created a table, I partitioned it. While creating the data, like say, I really don't know what is my access pattern. I just based on the data by looking at it, I just partition it. Now while accessing it, because my where condition is not part of the partition criteria, then it ends up scanning the whole data.
Even before you design the table, you should know your reporting requirements, and based on that, you have to create those partition columns and bucketing columns. And you have to ensure whatever the columns that they are used, those columns is used in your where column. If you are not using those columns, and how the high level will come to know, I will use the partition or the bucketing. It will not affect. So all these things interconnected.
Let us go there.
Yeah, all right. So so this is clear, correct? This is what you will be doing your day-to-day uploading file. Second thing is like what you will be doing in day-to-day, correct? So this is what we created from the shell. We created command, and then we executed this create table, something like this, correct? All these things. So usually in a real world, what we will be doing is we will be having some kind of scripts here. HQL scripts will be there, correct? And like what we do usually is like you write these scripts in a notepad. These are the standard commands, SQL commands. You put it here. You put it somewhere where you want to execute it in your directory here, and then using this hive-f, yeah, that's the file name you do. So you execute those files without
Batch mode of
batch mode. So this is what you do it here. So suppose if
From
I,
where to run, you can run from there.
yeah, from anywhere. So if I do it from here, correct? Yeah. Yeah. If I do this, so it will be fine. But this file is not there, correct? So you hive-f and then you give your.
If I wanted to run directly from Hive, then you can directly.
Hive-e you have to make, I think. But like for the commands, you can
Hive
do.
command.
Hive prompt.
Yeah, hive directly you can do it.
You can copy the SQL and then
No.
No, if I want to execute it like in Oracle SQL, you can just set there and you can use the file, right?
For that purpose only, you use a hive-f. It's simple way. Where we are putting multiple comments in one single file and then use this command to execute. If you have single command to execute, then just go to the hive and type it.
Yeah. So here hive-f and then you give your query here. So this is one thing.
it will show the result also, right?
Yeah, it will show everything. Shall we do it one?
Even drawing that to the model.
Huh?
Here, data is
You can do it that way. So I just wanted because this you will be doing it in your day to day.
You just use case greater than and indirect representation.
Yeah.
Just like Linux.
Yeah. What I believe what he is mentioning is something like this, correct?
Single version.
Yeah. Yeah. So you're going direction for this.
Redirecting the
Yeah,
result of the command to the file.
Yeah. Usually, like okay, what happens? Like if I do this, correct? Select star from customer. Now you have this report here, but you want to store these results in a file. So you store it in a file and then you send it in an email or whatever you want to do. Otherwise, you have to copy paste and do it. So this is what I just wanted quick and some of the quick things about when you write queries, correct? Most of the SQL queries will work, like standard selects will work, from will work, where will work, order by will work, your case statements, select case, when,
All NC will work.
in, huh?
All NC will work.
All I'm not sure, but like most of the things will work. I just wanted to because when, huh? Yeah. So this like select statement, when, else, aggregate functions will work, mean, max. They have many.
What doesn't work?
That's it. That's it.
So you mentioned this like a from and
Yeah, all this will work.
no, you said double. You comment it.
Which one?
This is from 388.
Yeah.
388 number.
Line number?
388. 388.
This one?
Yeah.
Yeah, this will work. Everything
You
will work.
commented this double one.
Yeah, yeah.
Where clause
You commented?
Yeah, this is coming.
You commented. Yeah.
where clause is not used.
Yeah. So like group by, order by. Yeah, and some more. Yeah. Yeah, second for the people who are new, correct? So most of the sequels will work. You can do it. Second thing, views will also work. So if you are new to views, you can create views like this. Command is create view name, and then you can do it here.
So how different is this view with the file? The table is going to state in the file structure. How different is it in the table? Table will define this.
It's the same as how in database view you have. Similar.
In table, when you create a table, you are creating a limited maps to which file system. When I create view, how is it being interpreted?
No. You create on top of table.
On top of table.
There are multiple tables. Okay, you write one single select. Okay, you keep running that. But if you want to store somewhere, rather than it is same for
Similarly, like table, like any table, on top of the view you have table underline. So the purpose of view is to have faster queries. So this will work. Okay. And the quick things which I wanted to, some of the data types, correct? Interesting data types. Yeah. So this one, array. This is the quicker one, because when you are designing your things, correct? So this is some of the things we will do. Select size. So here array is a data type, and this is the command I'm using it. Array. I'm creating an array of 1, 2, 3, and I'm giving the size for this one. It will print out size of an array. So when you are creating your structure of your data, you can use this array.
Yeah, there are some bad. There are two things. First, it's to the file. There, if you go through the documentation.
Yeah. So like, I will just quickly go through this.
So what is the array of what?
This is simple array of some numbers, and I'm printing out size here, size of an array element. So if I do this, correct? If I have one more, 4, then it will give me size as 4. So in your scripts you can use this array that way. Then we have map.
What is map there?
Yeah, map is like in like programming language how we have key value pairs. So here what I'm doing here, I'm printing the size of. So map is a structure. You have key as name and value as Himanshu, age again as key and value as this, and I'm printing the size. So here it will print 2 size of a map.
Is it real mapping?
What? Yeah, it's a real mapping. So yeah, so likewise you can have it. So like for example, yeah. So like if I do this, correct?
And how does the database is like?
Huh?
Map, name and
Yeah. Name and value, that way, and then you get size of this, because this is important data structure.
Map is not there in our normal, right?
Yeah.
Certain things. That's why I just wanted to put in here, because when you are designing, especially with the JSON data, correct? Like suppose you have a JSON data, like customer, or like how do you create a table out of it? So that's why you want to have this array and then all this. Your JSON is like root, and then you have this. So if you want to map it, so you will be using arrays or a map.
Able to load JSON XML files as well.
Yes, you can.
Not XML, only JSON.
JSON you can.
JSON and
How
what?
do you define it?
See, you can load everything. You can CSS, take everything. Load whatever you want. And you should know how to handle them.
Hash
Based
array,
on
hash
that,
array,
you have to
right?
create a table.
Huh?
Then
You
you
know
want
how
to
to pass
what
the
are
data. You know how to design that.
Yeah, lateral view you can.
Analyze it.
value of the array, under array you can put hash.
It will not automatically.
No, that is why it is the delimiter and all.
It is okay, but it's like XML application. How do they know?
JSON different couple of many things now. Okay, now
Yeah.
So suppose I have JSON file
Huh?
in form of input as JSON file.
Yeah, I will show you how like this. So that's why like array hash map is there, and one more thing here is structure is there. So structure with structure, you can avoid, you can increase your performance. Like in RDBMS, you have primary key, foreign key. You do joins, then you create your tables, correct? Like one to many that way, correct? So now if you look at this one, create table, correct? Person, simple. First ID is there, first name, last name, tenure. I have this address, and this is my structure. So I have street and I have city. I have like within this person who are this subordinates. So this person can be a manager and who are the reportees. So subordinates, I have an array here. So with this, just one table, you can have your whole structure instead of creating many tables and doing primary, foreign relationship, joins and everything. So let's do this. So I'm doing this, creating a table, person with this ID, and I have this structure, and then this is an array. Let's create this. So currently this table is empty. Now you insert elements. This is very pretty straightforward. Insert into table name. Select, I am doing it. This is my ID. This is my first name. This is my last name. This is my tenure. Then you use named underscore struct, and then you use here address is there, correct? And then you use street and city here. So I give street. This is the street. This is the city, and then here we have like subordinates. So you have the subordinates here. So likewise we can insert these statements. So I believe in a JSON, when you have JSON will also something like that, root, then you have parent, so you can map that as well.
Size also very.
Yeah, you can vary the size as well.
New table?
Huh?
Person table is a new table, you already created a
Yeah. This is how I created. This is the table here. Create table person, ID, first name, last name. You have struct here, and then you have like subordinate is an array. This is a complex table we are creating it. So this way you don't have to have create many tables. So like if you want to design this table, correct, using standard RDBMS, the way you will be doing, there can many ways, correct? No, there can many ways. So usually you will be creating a separate address table, might be, or you will be creating a separate subordinates table, and then you will be having some IDs, and then your primary foreign, and then you will be mapping it. All that you don't need it. You just have this one table, and then you insert this data, and then I'll show you how to pick a particular value from that table. So that way it's a lot faster. Because joins always whatever, why is faster? Because like if you look at this, correct, when we did this, when I did insert into person, correct, like query ID, total jobs, launching, map 135, succeeded, all this, this is map reduce program, they are executing it. This like in Java, we can write our own map and reduce program, correct? So Hive is a wrapper on top of it. So you all this is doing a map reduce jobs. So the more joints you have, correct, it will be more mappers and reducers and all those things you will be creating it. So now it will tell you all this duration about DAG and all those things. So all this you can avoid it. So now it has created this records. So now look at this query here. What I'm doing here, I'm doing select address dot street. I'm doing it. So address is coming from here, from this table. Create table person. This is the address. Select address dot street. address.ct from person where first name is Himanshu. So I want to get address and street and city where the first name is Himanshu. So this will give you your first name with those. So that's how you can map it. Second is again with the same thing, subordinates. So this is an array, correct? So array will have indexes will be there. So what we are doing here, select subordinate 0 from person where first name is John. So if you look at this data, correct, when we inserted somewhere, do we have first name here? Yeah, so here we have this first name, correct? So it will give this John and like subordinates is like this is an array, so it should output Peter. So this will output Peter. So this is about array structures and like all those things. Second thing, again on the same lines, correct? So like play with this explode and lateral view explode. This is where you will be using it like if you want to have a complex JSON, correct? You have a store or you have this data internal, external. Most of the data will be in JSON or it's like root will be there. So this will help you to get you can create your tables and then you can populate and do it. So yes, more than one array. Yeah, you can. You can.
So you can check that who are there, where the manager is the room, inside the area and inside the
Yeah, I guess you can. So okay. So what we are saying is that okay, what you want. Say like suppose we have this. Huh?
so search where that manager is.
Okay, so you want to do that, correct? Yeah. Likewise, for that we have this one. If I do this, correct?
Yeah, not first name. Independent of first
Yeah. Okay. First, let me explain this. Then probably we can answer your thing. So if you look at this, correct? What I'm doing here, I'm getting subordinates from person where first name equals to Himanshu here. So if you look at this, explode and lateral view explode. So now I get all the subordinates with Anuradha, Arun, Sweta, correct? This is where we have it. Yeah, now I'm doing, give me first name, subordinates from person, lateral view explode as subordinates for Himanshu. So this will give all the subordinates and like whoever the managers are. Yeah, this is. Did I miss that? Again, I have to create. So this will give you your subordinate and like corresponding like manager for that. That's how like you can do with lateral view explode. So you have this. So,
and it will move those like the where card will provide.
which one?
You will move where cards.
Yeah. Where?
Find out all the first name which is put in the
Find out all the first names.
first name.
Okay, so probably we have to do somewhere here, correct? Where first name equals to this. And subordinates will be 2, correct? Something like that. Yeah. Okay. You want to do it? Okay. What do you want to do now? And is it?
Select first name from personal, where this will be a source subordinate as expected equal to
This one? Like this?
we are searching inside the file, right?
Okay. But then you have to give equal, correct? Something like this.
Equal to, so your array, under array we have array, right?
Yeah.
So all the array contains the searching array.
Mm.
So where it's fine, it will return the
Yeah. If you want to do it subordinates, you can get it, correct?
The subordinate will get everything.
Okay.
You don't know where to do it.
Okay. Yeah. Okay. Okay, let's move on. Just say query. I just want to touch base the things here.
Just wanted to see how flexible the is not and
So and again you have alter table. You can use that. I think most of the things are there, and the same way, correct? So before we close on the Hive, because I want to go to the Spark and then do it. So so all this, like, because since this is more focused on Azure, so when you have these containers, correct? So we created all this. So I think I used 2. If you look at this, your data will be created in these blobs here. Yeah. So blob, and the blob has got container, and then you see here, like, upload. You can upload your data to containers there. Then going to Hive, correct? Hive warehouse. So all these tables, Naresh DB and all this Amit DB, they are all created here. So this is the same portal, you can use it. So now if you want to do it, correct? So all this is good, but what I have noticed with this is that if you want to use this portal to get the contents of this file, correct? It's not very easily to get the contents of that file. So there is one tool called Microsoft Storage Explorer. You can actually download it now. So what it does is that I have already downloaded it. You can download it from here. If you do Azure Storage Explorer. So you can think of this as like you have a database and then you have client, correct? SQL developer, how you connect to your database, and then you can get the view of your tables and database through your desktop. Similarly, you can connect to your blob storage, your storage, and you can get details about all your tables and the storage. So this is a handy tool. It's very easy to download. I will just show you what it is.
It's just like how we navigate through these 3
Yeah, same. Yeah. So yeah, this is a desktop tool. So like currently we have created these 2 storage accounts, correct? So here, if I go to, yes, Yeah. Yeah, I can. Yeah. You had any question?
Yeah, so if I delete the cluster,
Yes.
the storage account will not have any the files not uploaded.
If you delete your cluster in the storage account,
This container has no.
no, it will be gone. I believe it will be gone.
So everything is gone, right?
No, sorry. What you said? If you delete the cluster, what about storage account? No, it will be there. I'm not sure about the file.
Storage account, but files in that container.
Files in the container will be gone, I believe.
Okay.
Yeah.
No, but since containers are not a different cluster, if I create one cluster, you have some actually it still be available, right?
No, she's asking about the files in that container. Container might be there, but files will be deleted, I believe.
No, but the files are taken from one cluster.
Hmm?
So like right now, like I'm.
Yeah. See, like say for example, this one, correct? So this is our storage explorer.
Right.
We have blobs. We have this container, and in this, we have different files here. These are different files here, correct? Let's go to Hive here. Hive warehouse. Let's go to this the dm.db. We have this customer here. So you see this blob created. This is where our data is actually.
Actually, let's park this question somewhere there. Tomorrow at the end of the day, we'll delete the cluster and we'll see whether
Delete the cluster. How do you access it?
magically it should get it up. Otherwise, it will be lying there.
Unless if we pay for them, then I'm just they're taking it as a backup somewhere. Companies for it back, then they ask for money.
Yeah.
The moment you delete the cluster, that particular whatever the username that you create, you'll not be able to log into it. You'll not be able to access it. Or the other way around it, you might be having that Azure account. You need to go to that Azure account and then see like whether that container exists. If it exists, then see whether this exists.
Yeah, we can. Yeah, we can.
Containers to the cluster, and once cluster goes away, then we get the cluster.
Yeah. All right. So basically, this is about the storage explorer here. If you go to dm.db, correct? So through this, you can actually view the content. If you don't have command line or like, this is also a good tool to to look at this data here, because from the portal.
But first you have to allow us to log in, right?
Yeah. You have to log in. Like how you connect to any database, you need credentials. Like similarly, you need credentials.
Your Ambari and those.
Yeah, Ambari and your account details.
So my question is when you remove the cluster, those will not be whole good. So you cannot connect all this. If you delete that cluster, then you cannot connect to this particular. You want to Azure Explorer also.
Yeah. That will.
That is what I'm saying. Anyway, to command prompt, you will not be able to access. If you Azure account, you can still go to that storage and you can see whether the container
But
is
it will allow us to authenticate. We can't authenticate. If user is out, user is gone, then you cannot
No,
authenticate.
Azure account is different, your cluster account is different. So your Azure account, you still have access to that storage.
Okay.
See, that is where it's showing you that blob. Okay, by logging into that Azure, you have the different options. You have the storage option. If you go there, you will see all the files from there.
I think it's okay, but I don't think so.
The storage also, the cluster under your storage. If you delete it, it's not from storage. Unless you have it.
I think if you're that we have to see that. So like with this storage, correct? You can get the details. If you double click, what I'm doing currently, I'm double clicking this, and then and then it will show you your files, the content of that file.
So Mike, one quick question. Sir.
Yeah.
Of course, like we are not working on the space,
Yeah.
but like for today, like if they wanted to touch base, what I do is simply run the SQL and then see the data manipulation something like that.
Yeah, they can.
Because data, when you work on that project, I think probably you need to do it and then
Yeah.
see what I do. But normally for today, like when people can go home and then start working on it.
Yeah.
So they can just simply do.
Yeah, first they should, like, I believe like everybody has the credit card, correct? Yeah, so create an account for 200 these things. You should be able to do that, and then play around with how we spun up the clusters, everything. So and like it's like $3 or $4. So that you're not paying anything to that. So play around with that. Once you are done, you delete your clusters. I will show you how you delete everything here. So that way you can work around with your things and everything. And also the link which I gave you, correct? Like if you follow the same cluster name, RG and resource name, you should be able to run all the scripts. If you follow, like if you change your name, then you have to change your table names and everything. But you should be able to follow everything and like create that. Like tomorrow when we meet, if you have any question, then we can take about like how you do that.
Deleting is very important.
Hmm?
Creating
Yeah.
a cluster with the 200, it will 330, it will.
Yeah.
I just love that for every hour we started.
Yeah. So basically, this is about the Hive, about this file upload and everything. So before we move to Spark, correct? So just in case, so like earlier we spoke about this. If you go to Hive tables, correct? Like you can access everything from here, from your Ambari cluster here, from your Ambari. So So now if you see here in this, so we have created that many uh, databases here in this one. This is one, so Naresh DB, so you can see the tables here. So all those will be created here. So I log into 2, what we created, correct? Let me log into 2. So all these tables we created, database and this. So you can work from here as well. All these tables what we created here as well.
Yeah, customer data.
Using database. No, I didn't drop it. Huh?
Maybe these are the default.
So anyway, so if I do this, it will do this. Let's start now. But I would suggest in like real world, always play with your console command line. That's the best performance you will get it, because this data is coming from web page. You will always have little impact. So the best way to to solve any problem, go to the command line and then then do it here. So this is about Hive. So you see the data here for this, likewise customer ID and all this data is here. So now let's move on to Spark. Yes.
Like, sometimes like you try inserting like 5 or 6 statements in a like insert like after
Mhm.
these and all of those stuff.
Mhm.
Do you know like how exactly is internally to exactly not but how internally to exactly
Internally, no, I'm not aware of internally.
When you want to see, like, you can go to that monitor. Whenever you run that any job, okay, it gives you the link as well. Link, if you go to that link, it shows how many mappers were created, how many pillars were created, what is the status of that mapper, and what is the status of the reducer, and how much time it might take. That is all you can monitor from that.
Based on your query, right? Whatever the query you shoot, so whether you are selecting something like column pruning specific columns in the particular table, and you don't have any wear condition. It's just like your map only job that it runs. If you put your further aggregate statements or something like wheel maps or some joining conditions, then it will go for a read operation.
Okay. That is like when I'm putting it, when I'm trying to insert the data, because here I don't rely on that what is there in my database. I just rely on the data what is I'm trying to insert it. Let's say how exactly to insert the amount of.
Inserting, it doesn't do any amount. It's just the command line thing that it does for loading the data. Whenever you're trying to retrieve the data, processing comes into picture. That's
How
time command will come.
how many blocks of data you have in SPSS based on the respective.
Those many mappers it is going to. Now here we don't have mappers anymore.
So each block is explained prepared by something. Okay, one file can create 1,000 blocks. It doesn't mean 1,000 numbers.
Okay.
In each this thing, lab, if you just population is population, 4 node cluster, 1,000 divided by 4. Each node might contain 250 blocks data, block of that data. So that when you fire the select statement, based on where it is there, it internally understands that. And not only your query, at that point of time, multiple queries might be firing. No resources available. Still, it might need 4 mappers, but still, it may like, okay, it takes time, it will tell, okay, only 1 mapper. It might be associating only 1 mapper. It still wait for other 3 mappers to come. So that and all is internal.
Okay.
Takes a lot of time.
Yeah. All right. So let's move on
Those
to.
who work on the one, they are
So the blocks and all comes as you explained at the time of setting up the cluster and setting up your SPSS will decide what is your block size and what is your replication factor. You can say like you can even at the time of loading also you can mention. By default you might have set the 8 as your replication factor, like it should be replicated in 8 9. But while loading you may decide I don't want this to be replicated in 8 9. I just want it to limit to 4 9. Then you can even mention that as well. Then it replicated only in 4. So it doesn't replicate in this. Those data will be there in your master node. So when you fire your select statement, that master node will say like in all nodes this data exists. So and whether all the nodes are up and or running. If some data node is down and from there to take and all, that will come from the master node. So you extract all these things from the came up with this.
basically an entity database. Basically, the entity operator, the entity operator, same thing here also. Same.
So that is what it says. When you write simple select start from unit, it doesn't require any revision. Whatever it gets the data, it has to show you. The moment you write select sum, that means whatever the data that is coming from all these nodes, it has to be consolidated and it has to be reviewed. If there is 10 records based on your group by, you say like group of based on some XYZ column. So it just brings the data from all the mappers and then applies sorting and then applies revision. Then that's what amount of data that I should show to the user. If the output comes to 10 records, you might see only 10 records. But if you are not used at some by, then it becomes 100.
Yeah.
Files will be
We want to
changed or
do more focus on.
Block, that is block.
That is 128.
Whatever it is, you can even define that. Whatever you define,
Come up with
Every file is like a 1 GB. It will break like a 60.
So whatever the size we define it will break in that.
index size and blocks of the block size. See, in simple is you just create one file and a local file. Okay? And you write cat, okay, it directly goes there and it goes there. But if you have created the SPSS file, and if you don't use that SPSS file and you write the cat, it will error out. It doesn't give you the output. Why? Because that file is divided into multiple systems. That is why we use the SPSS command. Saying that, okay, this file you should get it from the cluster, not from the
The machine can be here, machine can be here also. Those are also.
All right. So yeah. So please everybody log in to one, and then we'll start with the Spark. So we'll have a little hands-on with this. And so once you are logged into the cluster, let me know. Then we will start with that.
You are putting in one, right?
Yeah, I am using two.
So you are going to do or one?
One. So bear with me if your program doesn't work because of the memory. So we will try to do that.
Send you through the Slack. Yeah, good luck.
Yeah, all right. So yeah, all right. So yeah.
So what about that phone that the remote Nirupa Vijay?
Nirupa might not have been.
She can, no?
No, she's
Hello.
Yeah.
Hello. Yeah.
Yeah.
I love them.
Okay.
Yeah.
Yeah. All right. So yeah. So okay. So like first, watch me out because I don't know multiple sessions are there. So on the Spark, I won't be going into theory about Spark and everything. While you go through it, I will be doing that. So like when you launch Azure cluster, correct, in your projects, you have SD inside. So this is what we start from. You create clusters. Morning we created Spark cluster, correct? So you do SSH using this. So if you click on this, you get SSH details. Let me do it here. I do copy paste and then I open a new terminal. Yeah. So I go here and I'm connecting to 2. So so far everybody on the same page, correct? Connected to 1. Yeah, connected to 1. So yeah.
One quick question. Sorry,
Yeah.
so Ubuntu. So they are using like otherwise Ubuntu.
Yeah, Ubuntu. Yeah. So this is where, correct? So now if you want to start, so this is what I'm showing you is a Spark shell. This is where you will be interacting your programs and everything. So if you are using Python, you use py spark and then hit enter. So now if you look at this, correct, it says Spark major version is set to 2. So when we install our cluster, we use Spark 2.1.0 here. So the latest, if you go to Apache Spark, so okay, they have moved to. Yeah. Yeah. So this is where you have all the documentation. So if you look at this, they have latest release as 2.2.1. So I think the stable one, which I mean you can use and like try it on, but I think 2.1.0 is a good candidate because sometimes all the latest, with I don't know how it is, but yeah, we are using 2.1.
So here is using Python version 2.7, right?
Yeah, Python version.
Python 3 then?
Huh?
You want to use Python 3 then?
I don't know actually because these are all the clusters already there, correct?
Okay.
So I don't know how. Yeah, I don't know how.
I think it is not yet supporting the Python thing.
Yeah. So now I will share some of the commands, correct? So basically, if you are looking at this slide, correct, about this. So Spark, again, people who are aware of MapReduce and everything. So like if you are asking what is Spark and everything. So the key concept of the Spark is like you do MapReduce. Definitely, you do MapReduce in that as well. But huh? So you do so basically you do MapReduce with the same like Hive also does MapReduce. Now why we need Spark, correct? That is the main thing. You can do everything in Hive. We showed in the morning files and everything. So difference between Hive and Spark, number one, Hive and all this they are file-based systems. So you write your programs, you store data in files, you process those in files and everything, correct? What they say Spark is 10x faster. So if you look at their slide here, correct? So they say Apache Spark is fast and general large scale data processing, runs 10x faster than Hadoop, MapReduce in memory, and all those things. So why says okay faster than Hadoop? Maybe because when you read and write from disk, correct, files based. So you read, you seek data, you write data to disk. It's like slower. Similarly, if you store anything in RAM, in memory, it's a lot faster. You are not writing it to your hard disk. You are getting it directly from RAM. That's why it's a lot faster. Everything you are doing processing, it happens in memory, in RAM. There is no file base as such, like temporary, all those things are not there. Okay, and yeah, and then one more concept of the Spark is they call it as what they say is that RDD. You will hear a lot of things when you look at the Spark literature, resilient distributed data sets and everything. But in a nutshell, uh, like what happens is that okay, first I will tell you why we need. I don't know whether people are aware of this or not. MapReduce, what is the concept behind this? Like just 2 minutes because it's important, and you will really appreciate what is that. In earlier days, in our client server programming, again, like in the client server programming, we have data running somewhere. We have database remotely. We have our programs in our laptop. We have Java program. We fetch data where our program resides. We do processing on that data. So data is coming from different networks. Different networks, our programming sitting somewhere, we get data. This is opposite. In the MapReduce and in the Spark, what we are doing here, data still is there anywhere. We have 3 node cluster. Data is somewhere in West US, in East Coast somewhere. Data resides there. What we do here in this big data processing, we send our programs to that data. So what is the difference? What makes it so good about that? Yes. So the size of your program, correct? Yeah, the size of your program is very less. 1 MB, your Java program, you write Java program, Python program. What is the size? 10 MB, 12 MB, 12 MB? How much it is? It will be very less. You send that program to your data where the data resides. Let those programs where the data resides do that processing in parallel. You can scale that, correct? You can scale that where the data is there, and there will be one program, driver program they call it. If you go at this part. So once the processing is done, those worker nodes they are doing in parallel is done. They send that data of your whatever your data crunching you are doing it, your result sets back to your driver program. This is simple concept, but like is like important concept. If you look at like why we have that thing. Second thing about this is that if one of your node goes down, one of your worker nodes goes down, what they say is that it's a very resilient system. So here I showed you one slide here about this transformation and actions. I will explain a little bit about that. Now what happens, like you have a, suppose for example you have a word, okay, you have a word. So word is storing word is suppose for hello, simple hello in like small case. That data is there, is stored somewhere in your that data is stored somewhere in your data in your server somewhere, correct? Now what the things about Spark is that like suppose you want to get hello from small case to uppercase, you want to have it simple thing, very basic thing. We are talking about very basic things. So like from the small case you want to make it as uppercase, you need a program for that, correct? So you ship that program where your data is, number one. Second is that like imagine there are a lot of hellos, like 1 terabytes of hellos in your database. All this you want to convert it to an uppercase. You can do it with a Java program, correct? It will take about 24 hours, 2 days, 3 days, correct? To get that data, do all those things. So you distribute that. Second is that when one of your worker nodes goes down, correct? So when I make that hello from small to uppercase, or from once I have it uppercase, I just want to extract only H first letter from that. This is my data processing. Data processing can be anything, but this is my use case. I have a hello. I want to convert it to uppercase, and I want to extract first character from it. This is my use case. Now when I do this, when I create from small to upper, I am doing transformation of that data. Okay. And then when I do transformation, again I want to extract another just one character H, capital H from that. That's what I want to output it. Okay. Again, I'm doing one more transformation. Correct. The similar you can do it in Java. You have a Java program. You do substring, all those things you can do it. Correct. So now, while I'm doing these transformations, like from small to capital, extracting this, once if any of the worker nodes goes down, correct, still you won't lose that data. If I'm in the middle of processing that, you won't lose that data. So they call it as transformations. And this is about lineage. Lineage in the sense like I have one transformation from lower to upper, from upper to extract one. Likewise, I can have n number of transformations. Now, this is about transformation what we are talking about. Now actions, correct? Now actions is like I want to group something or like count or collect something. They call it an actions. So unless and until, because when you are debugging your Spark programs, this is what you need to know that. So unless and until you don't perform any actions, so transformations will happen from lower to upper, from upper to extract one, and all those things will be there. But unless and until you don't call any of these methods like reduce, collect, aggregate, first, these are all actions. Nothing will happen. Nothing will execute. So they call it in that world as materialize. Nothing will materialize. You do thousands of. You can do map. Map is nothing but from smaller case to upper case. You do your letter, and then you filter. So you apply filter on that. I want to get only H or something like that. So all these they are transformations. Transformation doesn't materialize, doesn't execute till you perform any of these actions. This is very very important because people who are just starting with the Spark, this is like kind of like good to know that. So this is about the Spark, and then what happens because we will be doing hands-on with this, so you will understand what we are doing here, and then so once you have these actions, correct, and then the transformations, there is concept called RDD is there. So you will RDD and like data frames. RDD is nothing but like temporary. You can say data type. This in the Spark world it creates, which is like which understand like suppose for example if I'm doing from lower to upper and then I'm doing some extractions and one of the worker node goes down. So this fundamental concept of RDD through which it will again create the whole data for you. So there is guaranteed that you will never lose your data. You will never, if one of your cluster goes down, your worker node goes down, you will never lose even a what you call 1 KB of data.
Because of the copying here.
Yeah, because of this RDD
Yeah,
concept.
that's what RDD concept probably they mentioned. So they might
They
be
keep
copy.
it there in memory.
Yeah, in memory.
Yeah.
It's a lineage term that we use.
Yeah.
It's because of the lineage thing. There is the source of the data, and after that, the upper thing is there, right? So after that, there will be another transformation. And let's say here you lost it. So what will happen? You can build it from this. Again, this will be take. Again, this will help rebuild it.
But that they bring every data to memory. What?
Yeah, in memory.
In the memory.
Everything in memory.
Because of the lineage, it can build it back.
Yeah.
So,
So
like, good amount of overhead of IO over there, right? See, that's like, because like, if I'm running the matrices, because my job, my mapping, like, it always go line by line under the data node. It reads every line by line from the data node. But whereas when it comes to Spark, it is feeding the whole data from the data node into the in-memory. There's a good amount of overhead over there, right? Good amount of latency.
No, but it's not going every time you are running code, right? You are not doing back and forth, right? That is you are saving the memory.
But good amount of this IO.
They are taking IO because of this.
yeah, because of
It is memory intensive.
This is memory intensive. You have
No, memory intensive is one thing. I can enhance my memory as much as I can. But one thing that IO intensive as well. Because I am bringing all the data node data into the
One time. You are bringing it one time. You are bringing it into the memory one time. In MapReduce, what happens is you will have the temporary files and all, right? Intermediate files. So that will go to the disk. So here it won't go. Very rare, if it is not fitting to memory, it will go to the disk.
Yeah.
Small chunks.
Yeah. Okay. So like yeah. Another important thing, so I think we are at this basic clear about it. Another important thing in Spark, correct? So we spoke about RDDA. So there is concept of data sets or data frame. So nothing fancy about that. We have database, we have tables. Likewise, in the Spark world, we have tables. So RDD is like very low level of granularity you have it. You can work on that particular one piece of data and then you can do it. So, but that is what people are moving away from that because it's like a lot of overhead. When you work with so much data and you want to do some analysis, so so they come up with Spark SQL. So what happens is that you write like how earlier we did Hive and then we wrote Hive queries. Similarly, with the Spark dataset, with the dataset, we can write Spark SQLs. So when you do the Spark SQL, so probably if I'm a SQL developer, for me it's very easy to write queries, and for me it doesn't matter whether it's high or SQL, correct? I can learning curve is less. That is the thing, and then it comes up with a data set. The reason I'm mentioning because that's where like to go through the more Spark intensive things, right? So data set is nothing but tables, and each table has got row. So the row again has got RDD.
Like
So
the
they
Excel,
call it
Excel sheet.
Excel sheet.
You
Yes.
think about Excel sheet, you're looking up the column.
Yeah. That's all. And that Excel sheet is distributed across worker nodes. When you do some crunching, so all this data, all these Excel sheets, they are sitting in different data nodes, worker nodes. You have your programs work on those Excel sheets. You gather that data and then you send it to one final output program. Okay, this is where about the fundamental thing is about. Now, so like everybody is there here, correct? So now let's do some of these things here. All right. So this is very basic map we will be doing it here. I just want to show you here. Yeah. So just copy paste this.
Sorry, Spark SQL. We don't need to create tables now.
No, temporary table we have to create.
We have to create a
Temporary table.
which is on top of the SQL.
HDF data set. Yeah, I will show that. Yeah.
You can tag a schema.
Yeah.
Whereas RDD, you don't have a schema.
Yeah. So just entire thing. Follow me. Copy paste this to your console. Put it in Slack. So you have your Python program running, correct? Your PySpark. What I'm doing, I'm just copying.
You can copy this thing, yes?
Huh?
Just copy and paste.
Yeah, copy paste the whole thing and like observe what is doing there. Hmm? No, this is just simple. I just want to show the console. So like everybody was like able to do that. What I put in.
B1, A1, A1.
Yeah, B1, A1, correct? Hmm? Is that how about you? Huh? You are not able to? Okay, because I think people are, yeah, you understand that, correct?
He's giving a bind section.
Yeah, maybe I think like one of that is using it. So I think that's why.
So it has some limitations.
But
Yeah.
I'm not able to do that.
Yeah. Yeah, that's fine. I think like one of us, like once they are done, you can exit from this PY Spark. But like follow me. Yeah. So it's it's like PY Spark. Yeah. Huh?
We are actually going to execute a program, right, and see what happens.
Yeah, correct. So like from cluster, who was able to connect and like execute that? Is that? Oh, you are able to connect and execute it. All right. Huh? Okay, you are able to execute it, correct? Yeah. So like whoever was able to execute, can you do Control C, exit out of this, and like so that others can also try it out. Yeah, PY Spark.
You asked about Python 3. It is supporting Python 3 as well, but with Jupyter.
Huh?
CFS can also work with Spark Shell.
Spark?
Spark Shell also can connect.
Yeah. But that will be for the Scala. Only for the-
So I already connect out, but he is not able to connect to PySpark.
Yeah, because multiple connect. You are able to do it, correct?
I did it, I logged
Okay, yeah, logged out. So I think like some of the people were able to do it, some of them were not able to do it. So who are able to do it, just log out so that others can do it. So, but let me explain this here, what we are doing here. So here, look at this, correct? Spark session. So everything in Spark is related to Spark session here. And what we are doing here currently, we have executed, if I execute control C, I do, correct? I did py spark. So this is my Spark shell using Python. So if you look at what I shared, this is the Python program I shared here.
Is it Python?
Yeah, this is like Python, this one. What we are doing here. So SC, by default, when you run your Spark shell, correct? So SC is a Spark context. So for anything you do, you need to have a Spark session or you need to have a Spark context. So with that you can execute your programs here. That is the one thing here. So if you look at this, what we are doing here, we are doing sc.parallelize. This is just some sample data, BAC. Okay. When we say sc.parallelize, we are simulating a cluster here with BAC. Okay. Now what we are doing here is y equals x dot map. Now map is transformation. We spoke about that like a while ago. What we are doing here, and now in the Python or in Java or in Scala, correct? There is concept of lambda functions. So lambda is nothing but what do you say? So like kind of functional programming. If you look at the Scala, earlier we used to have object-oriented programming. We have objects and everything. So this is about function programming. Function programming is just a fancy word, but what it does is that it takes, you have a function, it takes some data, and then it applies some transformation. So like apply some transformation, and then that function, output of that function is another data set. Again, you apply the output of that data set to another function. So you can just keep on doing that chain of those functions. This is very popular when you are doing with Spark and everything. So yeah, so what we are doing here is that we are taking each element from this B, A, C. We are doing a map. So if you look at this, correct? We are taking B, we are mapping it to comma 1 here. So we are creating a tuple in Python, or you can say a data set we are creating. We are creating is B comma 1 we are creating. We are creating A comma 1. We are creating C comma 1. Now this is transformation. Now earlier we spoke about RDDs, correct? If I don't print this statement, and if we just have here, nothing will happen. The moment I do x dot collect, correct? So all this map will actually starting to execute it, materialize it will, and then it will give you the output. Now x dot collect. Now this is one of the things when you are debugging your programs, but this is very important here. When you do x dot collect, imagine you have 10 GB of data. Say suppose for example my laptop currently, correct, has 5 GB. Okay, forget about laptop here, actual we will do it. So this is our node, correct? So this cluster has got say assume 5 GB of data. It can handle space, correct? Now when I do this x dot collect, what it does, it gathers data from all the worker nodes and then outputs to one single program. This is our driver program, this console program. It outputs all this data to this console program, gets data. So if my data output is more than 5 GB, I'm just giving hypothetical example, but I will explain. Then our Spark program will crash. Okay, and like earlier we spoke about Java JVM, correct? So when you can configure how much memory your Spark programs can be. Now if my JVM, Java Virtual Machine, has a capacity of 4 GB, and if I have my worker node, this is my driver program. Driver programming means I'm doing something like this where I get the data. This is my driver program where I actually execute it. Now actually what is happening here, I did this, correct? SC dot parallelize and then hit on this. So SC dot parallelize BAC, all this piece of program is getting transferred to the worker nodes. The worker nodes is executing like we are doing SC dot parallelize BAC. The B is sitting somewhere in one worker node. A is sitting somewhere in some worker node. C is sitting in somewhere in one worker node. This program making a copy and going to those worker nodes where the data is. It will do that processing and send that data back to the driver program. This is called driver program. So the driver program, in a nutshell, rule of thumb is driver program memory should be more because where you are collecting your data. Otherwise, your JUM will crash and then you will have issues when you are debugging your programs. This is the major cause of your Spark programs getting hanged and like those not working. So if you look at this output, y dot collect, we are doing here as the B1 and like that's how you get here. This is our very first basic Spark programs, but believe me, once you understand this map, flat map, you can write any program. This is very fundamental. In Spark, we do all. That's what we do. That's all. So like another
What is the driver for Spark? What is the Java program which
this yeah.
No, that is driver. That is straightforward.
Yeah.
In the real life
Real life will be Java program will be there. I will show you that. Python.
Suppose we are calling for some, so that particular should be able to store all those records.
Yeah. That will be. I will show you that. Yeah. I will show you that as well. So yeah. So these are the different transformations. Let's take one more here. Flat map, because this is flat map. You will be using it day in day out. So let's take one more example here of this one. I will be storing this. So execute with me. Try this, but like this will this is very fundamental. So what I have done here is like x equal to sc dot parallelize. So we are creating like simulating that 1, 2, 3. They are in parallel. They are somewhere that data resides in some worker nodes. And then we do flat map. Now what we are doing, the flat map, like if you look at this, correct, we are taking 1 here. Again, this is a lambda function. We are taking 1 here. So 1 goes here to this function. So these are all, when you say flat map, these are lambda functions. So these functions, they apply on each and every element what you pass. So what we are doing here, we are having 1. We are putting 1 here. We are doing 1 into 100. And then we are printing out 42 here. So the first output is our is this 142. Now flat map takes another element 2. We do 2 here. We multiply 2 into 100, becomes 200. And then we have 42 here. And likewise, we have 3. We have 300. And so now if you look at this, correct? The output for this, once we have this in y, we are doing print x dot collect. So this is what we are doing it, and print y dot collect. Now if you look at this, correct, 142, 2, 242, 3, 342, this has become a list. Correct? This has become a list. In our unlike others. In our first example, what we did is like when we did output, we saw this one. B1 tuple, A1, C1 like this. So this is kind of like when you work around, you will see that. So this is what we do. This is trust me. This is all about what you call Spark and like like analysis. What we do here. So
This data set that is code as that.
huh?
So map is kind of a array.
Huh?
Map is kind of a array. You can say it's array.
Yeah, map you can say as an array. Map you do for each. So basically you create a tuple here. So like in Python they create it like if you want to map something, correct?
Value.
Yeah, key value pair something like that.
And flat is like this flat.
Yeah, flatten and then you make it as list or something like that. And now like suppose this is where it is. So this is I'm showing you console. Now you have a Python program or a Java program, correct? You can iterate over a list and based on a use case you can, so suppose if I say print out all 42s from here, how many 42s are there in this list? You can do it using your Java program or something like
It is at the top of the hive.
that. Huh?
It is at the top of the hive, top of the edge.
No. No higher. So yeah, I will come to that hive and all this interfaces with different systems, but I just want to touch base with this. So about this inner console.
Spark for data movement also. You can move data from
What is the reason for that purpose?
data movement data movement.
See, the difference is when you are loading that file, okay, and now that file is there in the memory, not in HDFS. So for processing, every time it reads the memory. It will not go to here in Hive, every time it goes to that physical hard disk, and then get it and process and then keep checking the
Pumps everything to memory. So memory is part
So the star quality does it, so it keeps everything in the memory. The moment it gets the file, it puts in the memory and it will be like
Yeah. So now I have sent you one more sample example. This is what you will be doing for this is like kind of a simple group by. So if you look at this sc.parallelize I'm doing. So we have B5, B4, A3, A2, A1.
Can we have a small break?
Huh? Yeah.
5 minutes.
Yeah.
5 minutes.
Hmm?
Ask API, inform team.
Yeah.
We're taking some break.
We are taking chai break.
Yeah, break.
But without chai.
The problem is much we are not able to connect like half of people connected. It's fine, we are not able to.
Yeah.
So better you display here because the understanding you can
Yeah. That is there.
running everybody can run actually.
Because you guys are okay so far. The pace is okay and you want a little bit slow.
No,
The important thing is I think we all have to practice.
Yeah, practice. Like one thing. Now we are following him, so we are okay. But once you go home, like
It happened many times.
Huh?
It happened many times.
No. Like I will show you how to install Spark on your machine. So without
no, Spark
cluster.
is like same like one of the command line only, or is there separate tool also? You can
No, command line also, but all these things you can create your own program. So after this session, you should be in a good position to work with Spark on your own.
Can we install on the back as well?
Yes, you can do it. Yeah.
for that.
Thank you. Just neighbor, $5. That's okay. Neighbor, charge or neighbor, $5 only. Just see that there is the time, right? No walking distance.